Hello, this lesson today I'm going to be talking about atoms and the different kinds of atoms and elements and so forth. Forgive my crazy hair. Oh well, it is what it is. Okay, anyway, so the first thing I want to talk about is what an atom looks like. And some of this is going to be review for you, but I wanted to make sure everybody's on the same page. So this is what an atom looks like. This is just one type of atom. Some of them have more or less of these and more or less of these. Some of them have up to like 100 and something of these and 100 something of these. Just depends on what kind of atom it is. Hydrogen only has one of these and one of those. Helium has two of both types of things in here and two out here. Every atom is usually made up, I shouldn't say every atom, but as a rule, general rule, every atom has what they call an electron. I know it's probably reversed for you. An electron, a proton, and a neutron of multiple, however many they happen to have of each one. They all have, every atom has electrons, protons, and neutrons. Okay. Happy atoms, I'm going to fold this for a second so I can show you the next statement without the rest getting in the way. Okay. Happy atoms, quote happy, they're not really actually happy because they don't have personalities, but whatever. Happy atoms have the same number of everything. So if I happen to have, in this case, this atom, this represents carbon because it has 6 protons, 6 neutrons, and 6 electrons. Okay. The biggest thing you want to look at is how many protons. Carbon always has 6 protons, always. The other numbers sometimes get messed up, but the protons, the ones with the plus sign here, always are the same no matter what. So if it has 6 protons, it's a carbon atom. If it has 5 protons, it's a boron atom. If it has 1 proton, it's a hydrogen atom. Every time, all the time, no matter what. Okay, a hydrogen atom might have 4 neutrons, but neutrons don't make any difference. It's just still a hydrogen atom because it only has 1 proton. In this case, it doesn't matter how many neutrons I have. If I have 500 neutrons, that's fine. As long as I have 6 protons, that means it's carbon every time, all the time. Okay, like I said, if it has 5, it's boron every time, all the time. If it has 8, it's oxygen every time, all the time. Okay, but these other numbers, the electrons and the neutrons, can sometimes be a little off. But happy atoms always have the same number of everything. Okay, so like I just said, the protons, let me fold it again, sorry. The protons are what determine what the atom is made out of. Okay, so if I've got, like I said, 5 protons, it's a boron. It doesn't matter how many neutrons it has. It doesn't matter how many electrons it has. If it has a certain number of protons, it's that certain element. Okay, it basically decides what flavor the element is, or the atom is. So it could be an atom that's an oxygen atom, or it could be the flavor of carbon atom. It could be a type, like that's the type it is. Like an ice cream scoop could be chocolate chip, or it could be vanilla, or it could be chocolate. Okay, but it's just the type of scoop it is. In this case, we're talking about whatever type of element or type of atom it is. So if it's a carbon atom or an oxygen atom or a hydrogen atom or a cesium atom or whatever it happens to be, just we have to look at how many neutrons or protons it has. That will always tell us what kind of atom it is. Okay? All right, now, like I said, happy atoms have the same number of all of these. So carbon will always have, a happy carbon will always have 6 electrons, 6 protons, and 6 neutrons every time, all the time, if it's happy. But sometimes atoms get a little bit upset and they don't follow the rules, okay? There's 2 things it can be. I'm going to fold it up again so you don't see both of them yet. Keep the other one secret for a minute. Okay. If an atom happens to have too many neutrons, so if it has too many of these things, which is the bigger bubbles in the middle here, okay? If it has too many of those, it's not a happy atom anymore, okay? Like, let's say this is carbon, 6 protons. If it had 10 neutrons, that has too many. It's not happy anymore. Okay, if it has too many neutrons, it's called an isotope. Instead of just a regular atom, it's just called an isotope atom. That's just the name we gave it, okay? Basically, think of an isotope kind of like an atom that ate too many neutrons for dinner. Okay, they don't eat, but you know what I mean. It ate basically too many of these, and so it has too many of those in its belly. So like, let's say 6 protons, it might have 10 neutrons. Too many neutrons. It's unhappy. It ate too much for dinner. It's got too many neutrons inside of it. It's just inside of its belly. It's full. It's not happy. It's not stable. Okay. that atom usually will start to puke, just like a person. If they eat too much for dinner, they have too much in their belly, they'll start to puke. They'll start to spew particles and just bleh, right? Okay, puking particles. An atom with too many neutrons in its belly will also puke. They don't really puke, but they also spew particles, especially if it's a radioactive type. Sometimes it can handle it, just like if you're sick, sometimes you can handle not puking. But in this case, if it's a certain, like uranium, for example, or no, lead, if it has too many whatever it's called, too many neutrons will eventually spew particles until it becomes, no, uranium will eventually turn into lead. It'll start to spew particles. It'll basically vomit. Okay, so these atoms that are isotopes, they have too many neutrons, and so it causes them to kind of spew particles. Those are usually your radioactive things. So like the bomb that got, or the nuclear reactive thing that got Chernobyl, that was graphite. That was radioactive and spewing particles. Okay, those particles come out with such energy that it actually literally cooks you. That's why they're dangerous. Okay, all right. The last type is if an atom has not enough or too many electrons. So now we're talking about these guys on the outside. A happy atom always has the same number. If it's got 6 protons, it'll have 6 neutrons if it's happy. Or if it has too many, then it's an isotope. But it'll also have the same amount of electrons, unless it's an ion. An ion is when it has this number for these little guys is off. Okay, it doesn't have the right amount. It has either too many or too few. If it has too many, that's an extra negatives, because these guys are negatives. So if I add an extra one, that means an extra negative. So I have a negative ion. If I take one away, it means that negative is gone. So now I'm now a positive ion because I don't have the right charge. Okay. So if an atom has too many electrons or too few electrons, it will become what they call an ion. Okay. And what ends up happening with these guys, let's say if I take this one away, this atom is no longer happy, right? It doesn't have the right amount of electrons. So what it's going to do is it's going to try to find another atom, like, I don't know, I'm trying to think of, anyway, whatever, I can't think of it off the top of my head. Another atom that happens to have an extra one, okay? In this case, he has not enough. We want to find an atom that has an extra one that can give away one. And so what it will do is try to find another atom that it can bond with, and we end up with a connection. They go, oh, you have an extra? I don't have enough. Let's share. And they basically connect together and start sharing their electrons. Okay, that is called bonding. And you'll see there's just several different kinds of bondings, but if an electron or an atom has not enough or too many electrons, it will share with other atoms. It will start to bond together, creating atoms or creating electrons. So for example, chlorine is missing one, and sodium has one too many. So what happens is sodium gives away its electron to chlorine, and chlorine and sodium are very happy together. Sodium chloride, if you've ever noticed, that is actually salt, table salt, okay? It's basically one atom with one too many and one atom with one too few, okay? That's what happens when you have the wrong number of those. So again, just to quickly review, an atom has inside the nucleus is the protons and the neutrons. The protons are the positives, the neutrons don't have a charge. And then the outside of the atom is the electrons, and these guys are negative charges, okay? Happy atoms always have the same number of everything. Unhappy atoms, if it has too many of these in the middle, too many neutrons in the middle, it's called an isotope, which then it will possibly spew particles because it's radioactive, often. And then the other type is if it has one too many or one too few electrons, and then it causes them to bond with other atoms, okay? Because they like to share their electrons. All right, now, you'll see this on the periodic table. You'll see something like this. In the periodic table, these numbers sometimes are moved around just a little bit, but usually they're kind of the same place. This is the symbol, so the chemical symbol or the element symbol. So this case is carbon. Up here it tells me how many protons it has. Remember I told you carbon has 6? In this case, carbon is number 6 on the periodic table because it always has 6 protons. Boron, if it was a B, would always have 5 protons, so it would be number 5. Okay, hydrogen is number 1, so it would have a number 1 here because hydrogen always has 1 proton. Okay, all right, so this is the atomic number. It tells you what atom it is, what type of atom it is. Number 6 means it has 6 protons in its carbon. Okay, this number on the bottom tells you what the average, if I were to take all of those atoms and I were to weigh them together, if I were to put them all on a scale and then average it out, this is the average weight for all of them. For every carbon, if I picked up a piece of carbon, one atom of carbon, this is what it would weigh, okay? And it doesn't have a unit because they just call it the atomic mass. So it weighs 12.01, right? 12.01, and it's a weird number because the protons and the neutrons actually weigh the same, but in this case, some of the atoms have an extra neutron in it. So the weird number comes from because sometimes the atoms have too many neutrons, so the number will be a little off, or too few neutrons, so the number will be a little off. Okay, so otherwise it would be a perfect even number, because remember, happy atoms have the same number for everything, so it should be 6 plus 6 neutrons to make 12. But in this case, it's 12.01 because a couple of them sometimes have an extra neutron in it, which gives it the isotope, which is an isotope. So sometimes carbon is an isotope. Okay. I did forget to say one thing about that. When you're weighing an atom, if I wanted to weigh this atom, there's basically 6 of these and 6 of these. There's 12 inside here. This atom would actually weigh 12. Even though it's got these guys weigh nothing. They're so tiny they don't weigh anything. So the atom only weighs the stuff inside. Okay? So an atom with 6 protons and 6 neutrons would actually weigh 12. The electrons don't weigh anything. Okay? So this is a 12 weight. So technically on here, this should just say 12 because it should have 6 protons and 6 neutrons and 6 electrons, which weigh nothing. But in this case, so it should be 12. 6 protons plus 6 neutrons equals 12. But in this case, we've got a 0.1 because on average, there's a few of these carbon atoms with an extra isotope, or with an extra neutron, that are isotopes with an extra neutron, which all averages out to being, instead of 12, it actually is a little bit more than 12. Okay, so this is just telling you that the weight of the atom is a little off because of the fact that we have some isotopes. You'll see this as well in your lessons. So I just wanted to kind of give you my take on it, make it a little bit simpler, kind of bring it all together for you before you have to answer the questions. But if you have questions, please let me know. Thank you.